All right, welcome to the Math 30-1 instructional video for 1.1. 1.1 gets into really important concepts in 30-1, which is the idea of function transformations. And the first way that I'm going to present it is the idea that we can write this out in function notation. And this is a struggle for a lot of students, but really what's happening here is we're comparing y equals f of x on the right-hand side, and then applying two parameters, h and k. Now, because of that kind of classic hassle with our graphing calculators, this really is how we should start, the expression I wrote on the board, but often what they'll do is they'll manipulate this to re-isolate y. And there's nothing wrong with that, but there's a pretty key difference between, the top line and the bottom line. Is that in the top line, we are subtracting k directly from y, but in the bottom line, we've moved it to the other side. And that is an important difference. And basically what it's going to do is going to make the rules behave a little bit differently. And we're going to completely right away identify what these are. H is what we call a horizontal translation. Horizontal translation, and that moves the graph right or left. When h is greater than 0, we go h units to the right. And when h is less than 0, we go h units to the left. All right, and maybe I should put absolute values here because we're identifying the direction from the sign. K, on the other hand, is a vertical translation. One of the best ways of identifying which is which is h is applied directly onto the x variable inside the function notation, and then k is applied directly onto the y variable outside of the function notation. So this is a vertical translation. Make sure I spell that right, translation. And very similarly, when k is greater than 0, we go the absolute value of k units up. And when k is less than 0, forgot the 0 there, we go the absolute value of k units down. And we'll examine this in the the notes themselves. Now, that's wonderful, and students typically don't struggle with that, the idea of what h and k do. Where this does become a bit more of a hassle or a bit more difficult is actually using this with function notation. So I just want to make a quick one up that if I made f of x equal to 3x squared plus 6x, I want to quickly show that if I was going to evaluate f at 2, this would be f of x, but anywhere there's an input, an x, I would replace it with what is inside the function notation, which is positive 2 in this case. What we're going to be talking about is what happens when I want to evaluate the function at x minus 2. Now, keep in mind that this is what we were talking about the previous page, that this is f at x minus h. Now, what that means is that in this particular context, h is 2. And the way that we can describe that is that this graph right here, the graph of f of x minus 2, would be the graph of f of x shifted 2 units to the right. And we'll develop that more in the examples to come. But f of x minus 2 would be 3 times x minus 2 in a bracket squared plus 6 times x minus 2. Now, if we were adding a number outside of the function notation, it's basically like it behaves as a square bracket. So if I asked you, okay, what is f of x plus 6? We would put, and I really do recommend these brackets, 3x squared plus 6x, that's f of x. And then after that, or outside of that, I would add 6. And again, this would be the graph of f of x above right here, shifted 6 units up. Okay, we're going to develop that more in the examples. Students typically don't struggle too much with the translations, but we are really going to try to make this clear so we can extend it to the vertical and horizontal stretches, which will happen in 1.2.